assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Calculating different energies. So for the first two problems, we're going to use the equation of E is equal to H times V, with H being our constant. So for A, we are given our V of 3.79 times 10 to the 11th. So E would be equal to 6.626 times 10 to the negative 34th. And then our V, that was 3.79 times 10 to the 11th. However, that would give us our answer just in terms of joules, and we want it in kilojoules per mole. So we are going to divide it by 1,000, and that gets it in terms of kilojoule. And then we are also going to multiply it by 6.022 times 10 to the 23rd. That gets it in terms of moles. So our final answer would then be 0.151 kilojoules per mole. Part B is very similar because they just give us another V value. So we have 6.626 times 10 to the negative 34th. Our V that was given to us of 5.45 times 10 to the 4th. Again, we are dividing it by 1,000 to get it in terms of joules, and then multiplying it by 6.022 times 10 to the 23rd. And when we do all that and multiply it in our calculator, you get 2.17 times 10 to the negative 8 kilojoules per mole. Part C is a little bit different. We're actually going to use a different equation. So for part C, we're going to be using the equation of E is equal to HC over lambda because we're given our wavelength this time and not V. So H is that same constant we've been using, 6.626 times 10 to the negative 34th. C is 3 times 10 to the 8th. Our wavelength that we are given is 4.11 times 10 to the negative 5th, and it's in meters, so we don't even need to change that into anything. We still will need to also divide by 1,000 to get it in terms of joules, and multiply by Avogadro's number to get it in per mole. And when you multiply all of that out, you get an answer of 2.91 kilojoules per mole.